The site, a plot with various organic vegetable crops in Unterstammheim in the canton of Zurich. The occasion, demonstrations of equipment for mechanical weed control in commercial vegetable production. The focus, weed control, between rows and, as a special challenge, within rows. Here we have millet. Over here is orage. Here's some chickweed. That is pigweed. In front we have yellow field cress. These two are also field cresses. And that already brings us to a fundamental rule. Weed control should start as early as possible, ideally from the cotyledon stage to the second or third true leaf stage of the weeds. This millet is now almost too big to control. If it is between the rows, it can still be destroyed, but in wet weather it will quickly grow back. The smaller weeds are ideal for cultivating. But when orage or millet like this is right between the rows, it gets hard to remove it mechanically. The biggest challenge in organic vegetable production is weeding within the rows. There are basically 4 different approaches. The oldest method is hilling, where soil is pushed into the crop rows. The weeds must be buried at least 4 centimeters deep to achieve the desired effect. Harrowing is another option. The entire surface is worked, not just in the rows, but also between the rows. Yet another option is the finger weeder. The plastic fingers of this implement extend into the row from both sides and cultivate. Yet another method for cultivating within the rows is hand hoeing or hand weeding. This is actually the usual way in sown crops. The other option is the available equipment that we have today, like this robovator that can cultivate within the rows, that is, between the plants. 12 different field-tested machines were demonstrated. Star cultivators are rear-mounted. The guide wheels are used to adjust the height and for lateral steering. A second person is needed for precise steering. The soil is initially loosened by goosefoot or pointed shanks. The weeds are ground up and then buried by the self-running star-shaped discs. The device works well in nearly all situations, whether the soil is dry or wet. The soil can't be too wet, however. The device works well even on somewhat larger weeds, as it is driven fairly fast. A large volume of soil is moved quickly, thus mixing the weeds and the soil and grinding them up. The star cultivator can be adjusted to move soil into or out of the row. Ridge cultivators originated in the Netherlands and are ideal for sandy soils. The goal is to control the weed at the earliest possible stage by cutting them off just below the soil surface with flat blades. With the ridge cultivator, it is also possible to hill the soil slightly. It is thus a combination device. The ridge cultivator itself is adjustable. When not needed, it can be raised for cultivation only. For hilling, however, it is left in position. The amount of hilling can also be varied. This cultivator is mounted on the Fobromobile, a self-powered lightweight equipment carrier. The chief advantage of this Fobromobile is the open view and the closeness to the implements. The implement can thus be adjusted very precisely and the driver can continuously check how it's working. Even with changeable weather, fieldwork can be resumed quickly thanks to the lightweight construction. Standard harrow technology has been upgraded with the Treflip Precision Flex tine harrow. The 500 mm long and 8 mm thick tines are fixed to the tension springs. The 90-degree angled tine tips penetrate the soil surface in a relatively shallow manner. The advantages are: neither the soil nor the crop is damaged. The weeds are uprooted and pushed up with the soil where they end up on top of the soil because they are lighter. The tension springs and thus the bearing pressure of all tines can be centrally controlled hydraulically or mechanically. The design also has advantages in raised beds. The tines in the ground under greater pressure pull and uproot the weeds, while the crop plants on the bed are gently cultivated with a maximum working depth of 2 centimeters. A standard toolbar with a frame and parallelograms on which the implements are attached. The torsion weeder can be combined with a blade cultivator. Torsion weeders are mounted on the individual parallelograms. They have tines like those of a rotary tedder, which converge to form a V and move through the lettuce. Due to the spring tension, the tines open and close as they touch the plants. The lettuce needs to be fairly well established, however. Cultivating only 2 to 3 days after setting would uproot the young plants. This technology is useful for weed control in well-established crops such as beans or lettuce. This finger weeder, mounted here on a Fobro Mazzotti equipment carrier, is used for cultivating within the rows of crops such as cabbage, broccoli or leek. Up front are shanks for loosening the soil and destroying and cutting off the weeds between the rows. These fingers, which engage with each other and which can be set to different intensities, cultivate within the rows. They literally twist the weeds out of the crop. The finger weeder is driven by an inner metal rim equipped with iron rods, which turns when the rods contact the soil. It is thus possible to work at a fast pace. The challenge in this cultivation technology lies in the correct settings. That isn't always so easy. These fingers are less effective if, for example, there are large clods in the field. If the soil is too dry, they may not break up the crust. If it is rocky, the fingers may be broken off. Those are the challenges. Here, the weeds within the lettuce rows are selectively cut from between the individual plants with cultivator blades. Fix-mounted goosefoot shanks weed between the rows. Digital cameras record the position of the lettuce plants in each row. A freely turning wheel equipped with sensors on the back of the implement transmits speed and working depth data. With this information, the computer in the cab digitizes the identification of the crop plants in the rows and converts the data into control signals which cause the cultivator blades to move around the plants. Thanks to the onboard electronics, the height control and sideways steering of the entire implement are fully automatic. Cultivators like this one from Schmotzer are constantly being improved. The cultivator is automatically controlled and can be operated by one person. A hydraulic cylinder moves the equipment carrier frame to the left and to the right. The cylinder is controlled by a computer in the cab, which receives image data from a side-mounted camera and compares them to pre-programmed values. Here it is being used in beans with 50 centimeters row spacing. 3 goosefoot shanks per equipment carrier are mounted on flexed tines. Heavy as well as light soils are thus ideally worked. Protective discs and plates divert soil and stones from the crop plants. In combination with finger weeders, weeds within rows can be eliminated. The brush hoe principle has been in use in agriculture for several decades. This brush hoe is mounted on an equipment carrier between the axles, where the driver can easily see and control it. The frame is fastened to a parallelogram, so that the brush can swerve and the height can be precisely adjusted. Hydraulically powered brush wheels sweep out the weeds between the rows. They simultaneously produce a fine soil layer, which torsion weeders push into the rows in a second step, thus burying the weeds in a cotyledon stage. A tunnel protects the crop, thus enabling a head start on weed control. The Cress Duo parallelogram is used in delicate crops like carrots, onions or herbs. Here too it is necessary to cultivate as close as possible to the crop.
Wir nennen es Duo-Parallelogramm, weil alles zweimal Duo.
We call it the Duo parallelogram because everything is double or duo. We have 2 guide wheels. To the left and right of the row we have 2 cultivator blades with discs in front, and for raised beds, side cutters on the rear that cut along the side of the bed. These leading discs are very small and sharp. They cut a furrow so that the angled blade behind them does not get clogged.
Nicht verstopft.
These are the requirements for successful operation. A fine level seed bed is needed. For the type of work we're doing today, the raised beds must have the ideal shape. With irregularly shaped beds, I can't get the ideal setting on my implement. All I can do is work deeper in order to get everything. The result isn't as good. In other words, preparation is just as important as the implement itself. The bed disc weeder, ideal in the early stages of raised bed crops. Here we have a standard toolbar equipped with discs fastened to parallelograms for cultivating carrots. By rounding off the edges, the implement can reduce the area that needs to be hand-weeded. This implement can be driven very close to the carrots, thus leaving very little to weed by hand. Precision steering of the implement and the right weather conditions are required for optimum results. Soil conditions are critical. The implement is less effective if the soil is too cloddy or very dry. In this case, the implement must not be driven too close to the crop, as large clods may be caught up and tear out the carrots. But if the soil is slightly moist and the soil structure just right, the implement is very effective and does a good job. There is a wide variety of multi-row rototillers. They are mainly used for crops that need longer growing seasons. This model is designed for cabbage. With high weed pressure or crusty soils after heavy rainfall, the rotors with blades can loosen the soil to a depth of 10 centimeters, thus obtaining fine soil suitable for additional cultivation with, for example, the finger weeder. The weeds are simultaneously chopped up. If the crop is too big, it is no longer possible to drive down the rows, as there is a hazard of tearing the leaves off the plants. Yet another hazard is posed by large stones, which can jam the blades. Weeds that propagate from roots pose additional hazards, as each cut piece can give rise to a new weed, and the machine itself may spread them to other crops. Another important weed control method, the false seed bed, is based on the idea of controlling weeds prior to sowing. The beds are prepared and rototilled about 4 to 6 weeks beforehand. The weeds are allowed to germinate. Then the field is worked with a shallow cultivator to a depth of 2 to 3 centimeters. The emerged weeds are still tender at this stage. The flat blades cut them off below the surface, where they dry out and die. The implement works like this. The machine has flat goosefoot shanks that undercut the soil at a relatively shallow depth of 2 to 3 centimeters. The shanks do not push the soil, so no ridges are formed. The object is to move the soil as little as possible. The weeds are cut off and pushed to the surface, where the roots are exposed and ideally dry out. Some sunshine is needed. With rain, it wouldn't work. There is a broad spectrum of field-tested equipment for successful mechanical weed control in vegetable production. For vegetable production advisor Martin Lichtenhahn, the potential for future improvement lies in finding the ideal combination of devices. When you see this equipment in operation, you think of optimization. How can we improve this equipment and make good tool combinations? For instance, mounting a series of tools on one equipment carrier so that different tasks can be accomplished in a single pass. I believe that this is where the real potential for improvement lies. Standard hand weeding is also being improved. Nevertheless, reducing hand labor in the field and making organic vegetable production more economically viable continues to be the focus of all involved. We have made great strides in reducing manual labor substantially, but progress continues. Farmers and research institutions such as Fiebel will work together with the manufacturers to continuously improve the equipment.